Session 8213, School of Education, SGDP 6133, Quantitative Data Analysis in Education, Regression Logistic. Our group members are Shanti, Jayalakshmi, Manjula, and Arinitya Rubini. A binomial logistic regression, often referred to simply as logistic regression, predict the probability that an observation falls into one of two categories of a dichotomous dependent variable based on one or more independent variables that can be either continuous or categorical. Regression logistic. Regression analysis is a type of predictive modeling technique which is used to find the relationship between a dependent variable, usually known as the y variable, and either one independent variable, the x variable, or a series of independent variables. When two or more independent variables are used to predict or explain the outcome of the dependent variable, this is known as multiple regression. Regression analysis can be used for three things: forecasting the effect or impact of specific changes. For example, if a manufacturing company wants to forecast how many units of particular product they need to produce in order to meet the current demand. Forecasting trends and future values. For example, how much will the stock price of Lufthansa be in 6 months from now? Determining the strength of different predictors, or in other words, assessing how much of an impact the independent variables has on a dependent variable. For example, if a soft drink company is sponsoring a football match, they might want to determine if the ads being displayed during the match have accounted for any increase in sales. Regression analysis can be broadly classified into two types: linear regression and logistic regression. In statistics, linear regression is usually used for predictive analysis. It essentially determines the extent to which there is a linear relationship between a dependent variable and one or more independent variables. Logistic regression is a classification algorithm. It's used to predict a binary outcome based on a set of independent variables. There are three types of logistic regression: binary logistic regression, multinomial logistic regression, ordinal logistic regression. And now we will see how to do the binary logistic regression. First, we have to click on the button Analyze and we search to regression. After that, we click on binary logistic. Then we have to insert the dependent undi, and into the block 1 of 1 we have to insert umur, taraf kawin, jantina. Then we have to click on the options. Here we have to make sure that we had tick the box classification plots, Hosmer limb show goodness of fit, case-wise listing of residuals, correlation of estimates, iteration is 3, CI for XP, and the outliers outside is 2. On the display, we have to click on at each step. And we have to make sure we got tick at include constant in model. Then we have to click on continue. And the output result as shown next. The first one is case processing summary. The case processing summary shows that there are 150 cases altogether and no missing cases. Dependent variable encoding shows that the one who don't want to vote is represented by 0 and those who want to vote is represented by the binary code 1. We can see that the constant model is equal to 0.634. It means the possibilities to vote is 1.885. It means 98 respondents out of 150 decide to vote and 52 respondents decided to not to vote. For this logistic regression, we can see that this model is significant where the value is 0.01, 0.01, 0.012, which is less than 0.05. Logistic regression estimates the possibilities of an event to occur. In this case, the possibilities to vote, if estimation possibilities is more than 0.5, so the possibilities the event to occur is high, and if less than 0.5, there are less possibilities. Variables in the equation table to predict the probability of an event occurring based on one unique change in an independent variable when all other independent variables are kept constant. The wall test is used to determine that each variable is statistically significant. Significance of this test can be seen from significant column. From the result, we can see that the variable umur 0.103, taraf kawin 0.467 is not significant to guess the model, and the variable jantina 0.01 is significant to guess the model. We always refer to odd ratios for each independent variables in column XP. It explains the changes in odd ratios for each one unit increment of independent variables. For example, for the variable of umur, increment of each unit will increase the odd ratios around 0.959. Thank you.